All right, today we're going to tackle a concept called parametric unification. I know, it sounds super academic, maybe a little intimidating, but trust me, don't let the name fool you. Behind that jargon is a brilliantly simple idea for building smarter, more flexible systems. So let's just dive right in and see how it works. To get us started, I want you to really think about this question. Imagine for a second you're an architect, and you've been given this massive project, a 50-story skyscraper. Are you seriously going to sit down and draw 50 completely different, unique, from-scratch blueprints? No way! I mean, that would be an absolute nightmare of inefficiency. So, how do you actually do it? The answer to that puzzle is the key to this entire topic. And the solution, whether you're talking about architecture or code, isn't about doing more work. Not at all. It's about creating one single, really intelligent master blueprint that can adapt to whatever you need it to do. It's the classic case of working smarter, not harder.
Okay, so this table breaks down our skyscraper analogy into three really important parts. First up, you have the parameter. Think of this as the variable, the thing you can change, like a floor's height or the material you're using. Next, you have the core logic. This is the master blueprint itself, the stuff that doesn't change, like where the support columns go. And finally, you get the unified element. This is the actual floor that gets built based on that blueprint. This is where the magic really happens.
And this slide just perfectly shows the payoff. By changing just one little parameter, in this case the floor height, our single master blueprint can spit out a standard office floor, a grand high-ceiling lobby, or even a double-height mechanical floor. See? One blueprint, tons of specialized results. If you remember anything, remember that.
So, we've seen how this powerful idea works with buildings. It's pretty intuitive, right? Well, now we're going to see how it has a perfect parallel in the world of software development, where things like efficiency and being adaptable are just as critical, if not more so.
And here it is, our official term, parametric unification. It's really just a principle for building one highly adaptable piece of code instead of a bunch of rigid, separate ones. Just like our skyscraper blueprint, it lets a single function or component handle all sorts of different types of data without you having to rewrite it from scratch every single time.
Now, if you're a developer, you have absolutely seen this in action. In most modern programming languages, think TypeScript, Java, C#, this whole principle is put into practice using a feature called generics. That's the tool that makes this whole one blueprint approach possible in our code.
So, what does this actually look like in the real world? This is where you see just how elegant this idea is. Let's call it the one function rule, because it's all about getting rid of repetition and creating code that's clean and reusable.
Man, this slide just says it all. On the left, you've got the bad design. If you want to get the first item from a list, you have to write a function just for strings, then another one for numbers, another one for users. It's like drawing a brand new blueprint for every single floor. It's a mess. But look at the right. The good design uses one single generic function, getFirstItem, t. It works for any kind of list you throw at it. One blueprint for all the floors. It's clean, it's efficient, and it is so much easier to manage.
This quote from our source material just perfectly sums it up. It says it's a mechanism to write a single piece of code that can work correctly with multiple different data types. The keywords there are single piece and correctly. You get all this amazing flexibility without giving up safety.
Okay, so it makes our code look cleaner, sure, but why is this such a big deal in software design? What are the real big picture benefits that make this something you absolutely want to use when you're building serious, scalable systems?
Well, it all really comes down to three massive benefits. First, reusability. You write your code once, and you can use it all over the place for any kind of data. Second, type safety. The system stays robust and protected from a whole class of bugs because it still understands what type of data it's working with. And finally, maintainability. I mean, think about it. When you need to make an update, is it easier to fix one master blueprint or 50 different ones? It's just simpler.
The crazy thing is, once you see this master blueprint pattern, you'll start noticing it everywhere, from how cars are manufactured to how legal contracts are written. It's this fundamental way of solving complex problems in an elegant way. So that leaves us with a final question to think about. Where else could this one blueprint rule simplify our world? Something to chew on. Thanks for tuning in.